Okay, so let's take a look at a simple question about this simple algorithm that I just presented. So this is what your WebGL is doing behind the scenes. The graphics card handles it this way. WebGL passes it through. And when you turn on the GL enable depth test, this is what's happening. So let's take a look. If I launch the polling, let me launch the polling. Okay, let me know what you think. What's going to be the state of this Z buffer? I only got about 2/3 of people voting. Rest of you, I'll take your pick. So we have a pretty even mixture of what people are guessing. So let's go through these answers. So as usual, we'll start with the most common answer, which is here C. And let's take a look at what would be in the Z buffer. So the first question we have to ask is, what do we start with in the Z buffer? Remember, what we're going to store here is the closest object, whatever the closest object is, and we're going to test. So in this case, it looks like we started with 0 in the Z buffer. So if we start with 0 in the Z buffer, and then we go and we render our red square, and this is from 0, 0, 1, 0, 1, 1, 0, 1. So it's going to be around this region. So we're going to write a number into this box. And we're going to test depth 1. So our test is going to say, is 1 closer than 0? No, 1's further than 0, so don't write. So we've come to the first problem that we have. Initializing with 0, this is the near. This is near, so we didn't want to initialize with near. We want to initialize with far. And in this example, 9 is our far distance. So we wish we initialized the Z buffer. When we do our GL clear call, we've been doing GL clear color often to black. There's also you can set an option to clear the depth, which is what you had to do to make this work. And there's a default value, but you can also set what are you going to clear your depth to. And so we want to clear the depth to the far value. So we don't like these ones that started with 0. We wish that we're one of these answers that starts with 9, because when we do the depth test, we want to say, hey, we're closer than whatever was there before. Let's go update the color buffer. So it has to be either A or B. It's not going to be C or D. So then we're going to write a 1 here into our depth buffer because our distance was at 1. Now we're going to go deal with our green square. And it's going to be in this range right here is our green square. And so this is at depth 2. So we're going to come to this first pixel here, and we're going to say, is 2 smaller than 1? No. So we don't update. So we leave the 1 here. And then when we go to these other pixels, these are still set at 9 because the red square only messed with this first one. So then we're going to go update these, and we're going to say, are we closer than 9? Yes. So we go ahead and write 2 into these boxes. So the correct answer should be this one. So we start with far, and we're going to update only these 2 places where we drew our 2 things. There's nothing about red or green because we're talking about the depth buffer. There would be a separate color buffer that would be showing the red and green. And if we did the 2 first, it would be okay. If we drew this square first, and we came back and did this square, because when it goes to write this, it would be closer than the 2, and it would overwrite. So we're completely order independent. It doesn't make any difference which triangle or square goes before whichever other triangle or square. So let me take questions about the Z-buffer algorithm, this question that we just had, anything about this algorithm. Who's got questions? Type them in the chat box or audio, whichever you like. Okay, you guys shouldn't be shy to type questions because obviously this was a very confusing problem based on the full results. The question is, was this quadrant 1 because this was placed first? Now this 1 is referring to the Z distance. So it doesn't, yeah, great. Thanks for the annotations. I can't talk and annotate at the same time. Yeah, thank you. Perfect. Those are going to be the colors. Thank you, somebody. The reason that this thing is going to get 1, right? So this is where the red square is. The red square is going into here. The green square is going in this whole region. And so the question that we have to decide is what's going to go in the depth buffer. And what's going to go in the depth buffer is the Z distance to that object that we stored in the color buffer. So if we do this first, all of these things started out with 9. They initialized to the far distance. And so 1 is closer than 9. And so we're going to go ahead and update and write a 1 here. Had we done the green square first, these would have all gotten 2 in them. And then when we came and did this, 1 is still closer than 2. So we would have still updated it to 1. So it doesn't matter which one went first. Other questions about this? We would initialize everything to the far Z. In this case, because I said Z equals 9 is far. Now, what would the real numbers be? Really, in your depth buffer, you're storing some fixed point or floating point value. Depends on how many bits there are. Also, in order to make this problem clear, I've said 0 is near and Z is far. But if we're 9 is far. But if we've organized our world to be looking down the negative Z axis, like we saw previously with our camera, right, we might really be flipped the other way. It might be that positive numbers are closer and negative numbers are further, right? So you have to get all these polarity things right. But in this problem, we've defined the Z0 near and Z9 far. So it should be clear. We want to initialize to far because what we're going to test is were we closer. And anytime we're behind an object, don't draw it. Don't draw when you're behind. So 9s are the default in this problem. That makes sense?